All right, first thing to do this lab, you're going to need two apps on your iPad. You have one of them probably already, and that is this app, Graphical Analysis. So it looks like this. The second one is called Video Physics, which has this icon. So if someone in your lab group or a couple people in the lab group have these apps, hey Tim, on their iPad, then you definitely can do this lab. So the first thing to get started is open up Video Physics, and it's going to look just like this. And then what you're going to do is you're going to tap on Create an Experiment. And then when you tap on Create an Experiment, go ahead to Take Video, which is going to take you to this next screen. You should now have a picture or a video going of your roller coaster with the ball on the track. And now what you're going to do is you're going to take the video. So go ahead and hit the play button on your video and let your friend drop the ball and try to capture all of its motion. One thing that I forgot to put in here, you're going to want to have a meter stick completely visible in the picture. You could also do with a 30 centimeter ruler. We need that for a point of reference so the program knows exactly how long like a centimeter is in your video. Okay, once you're done with your video, you want to go, it's going to take you to a screen like this. First thing you want to do is go to Origin and Scale, and you want to find your meter stick in your video, and you want to put this end at the left end of your meter stick and this end of this at the right end, and then you want to tell that it's 1 meter long. Obviously, if you use something other than a meter stick, if you use like a 3.1 meter stick, then you're going to make this distance 3.1. Whatever you choose to use, make sure that's the right distance. Then you're going to begin tracking the ball. So the way you're going to do this is, first of all, take this target and you want to put it on where the ball is starting, and then you're just going to tap your screen, and that's going to take you forward each second. The first few taps probably will be very frustrating as the ball has not started moving, but once the ball starts moving, each tap, you move this target so it is matched up with the center of the ball, and you keep tapping. You'll get a series of red dots, which eventually looks something like this. And now from this, the program is able to get the data about the velocity of the ball, and let's take a look at how to do that. So once you have your red dots, what you're going to do is click on the upper right hand corner, the little box with the arrow in it, and you want to do Open In and find Graphical Analysis, and this is going to take you to a program where you can analyze your data to get the velocity of the ball, and that looks like this. Okay, so it's going to take you to a page that looks like this. You're going to have the position versus time graph and a velocity versus time graph. So the first thing we're going to do is we're going to manipulate this position time graph so it looks like something you recognize. So if you click on the y-axis, it'll take you to a screen that looks like this. Okay, and then once it takes you here, you want to unselect the x-axis. We're only interested in the y displacement because this will look exactly like our roller coaster. So go ahead and unclick X so Y is selected. Okay, so once you've selected the Y-axis, go ahead, Aaron.
On the second or the fourth page of I would like.
So once you've selected just the Y-axis, now this is the part of the graph where the ball wasn't moving, but you see here, the shape of the Y will follow exactly the path of the ball, and so we'll know exactly where the ball was at what time. So what I would do then is if you put two fingers on this graph, you can stretch it out, move 1.5 or move the starting point of your graph to here, so you have a kind of a full look at things. And now we're going to go down here and we're going to select just the x velocity on this. So I'm going to click here. Okay, so what I see here now is when I just select x velocity, I want to move my y-axis on my velocity time graph so that the times match up exactly. In other words, 1.5 matches up with 1.5, 2 matches up with 2. And now what's awesome is if I click on this x velocity, I can match up a velocity at any point along this path. So say I want to find the velocity when the ball was there. I go right there and I find the velocity there, and that will be my x velocity. Now, you're going to have a little bit of work cut out for you because we also have a y velocity. The ball is moving in two directions. So you're gonna for each of the 7 spots, you want to write.
Sorry.
You okay?
Probably messed up your video a bit.
That's all right.
Leave it in the video.
Yeah, it's totally in the video. That was Mr. Miller, by the way. Once you have your x velocities, your 7 x velocities, go ahead and click on the y velocities and find those 7 y velocities. And then what you're going to have to do is for each spot. So let's say for spot 1, you got a velocity of 3.1 meters per second in the x, and in the y, you got a velocity of 1.1 meters per second. You need to do Pythagorean theorem and find the resultant velocity to find v total for each of the 7 spots, and that will be the velocity you use in your calculations for kinetic energy, which remember Ke equals 1/2 mv squared. So that's the equation to use. Let me know if you have any questions. Hopefully that helped.